This is the second video on coordinate geometry, and in it we'll be looking at problems involving parallel and perpendicular lines. These are two parallel lines. The red one has an equation 2x plus 1, and the blue one has the equation 2x minus 1. They have the same gradient. In general, two lines are parallel if they have the same gradient. So if we have two lines, y equals m1x plus c1, the red one, and y equals m2x plus c2, the blue one, then these two lines are parallel if m1 equals m2. These two lines are perpendicular. Now, if we look at the red line, then we see that if x increases by 1, y increases by 2. So the red line has gradient 2. For the blue line, we can see as x increases by 2, y decreases by 1. So in this case the gradient is minus a half, minus because of the decrease. Or we can say as x increases by 1, y decreases by a half. So gradient, as I said, is minus a half. So we can see that the two gradients, 2 and minus a half, if we multiply 2 by minus a half, we get minus 1. And this is always true of lines which are perpendicular. So in general, two lines are perpendicular if m1 times m2 equals minus 1, where m1 and m2 are the gradients of the two lines. This can be written m1 equals minus 1 over m2. So we have one gradient is minus the reciprocal of the other gradient. Now, determine whether y minus 3x plus 3 equals 0 and 3y plus x equals 6 are parallel, perpendicular, or neither. In order to decide whether lines are parallel, perpendicular, we need to write them in the form y equals mx plus c. So the first one, y equals y minus 3x plus 3 equals 0. We have to take the 3x and the 3 onto the other side, so we add 3x and take 3 from both sides, and we get y equals 3x minus 3. So the gradient, we call it m1, is 3. And for the second one, 3y plus x equals 6. We'll subtract x from both sides, we'll get 3y equals minus x plus 6. And then we're going to divide everything by 3. So we get y equals minus a third x plus 2. And so the gradient of this line, we'll call it m2, is minus a third. And then if we multiply m1 by m2, we get 3 times minus a third, which is minus 1. Hence, therefore, the lines are perpendicular. Now we'll do some problems involving parallel and perpendicular lines. The first one, the line L is parallel to 2y equals 3x plus 4 and passes through the point minus 1, 3. Find the equation of L. So in this, for this problem, we have to find the equation of a line. So we need the gradient and a point. We have a point, so we need to find the gradient. So the gradient of the line L is parallel to this line 2y equals 3x plus 4, so they have the same gradient. So we need to find the gradient of 2y equals 3x plus 4, And so we need to find it in the form y equals mx plus c. So we need to divide by the 2, so have y equals something. So we get 3 over 2x plus 2. So the gradient m of the line is 3 over 2, and therefore that's the gradient of L, which is parallel. So to find the equation of L, we'll use y minus y1 is mx minus x1, and substituting the values for x1, y1, which are minus 1, 3, and m is 3 over 2, we'll have y minus 3 equals 3 over 2 x minus 1. And to simplify that, we'll have y minus 3 is 3 over 2 x plus 1. And now I'm going to multiply everything by 2. 2y minus 6 equals, and then I'll expand the bracket 3x plus 3, and then I'll write 2y equals 3x and add 6 to both sides plus 9. Now sometimes a question will ask for this to be written in the form ax plus by plus c, and if it does, we have to equals 0, I should say. We have to write everything on the left. 2y subtract 3x subtract 9 equals 0, and we must have integer coefficients when we do that. So that's the answer to that problem. The second problem is the line L is perpendicular to the line 2x minus x, 2y minus x plus 3 equals 0 at the point 4/2. Find the equation of L. So again, we need to find the gradient of the line 2y minus x plus 3 equals 0. And in order to do that, we write it in the form y equals mx plus c. We'll add x to both sides and subtract 3, and then divide by 2. And so we have the gradient of this line, m is 1/2. Let's call that one m1. So we now need to find the equation of the gradient of the line L, and it's perpendicular to that. So we know that m1 times m2 must equal minus 1. So 1/2 times m2 is minus 1. And so multiplying both sides by 2, m2 would be minus 2. So the gradient of L is minus 2, and it passes through the point 4/2. So again, we have m is minus 2, we have the point 4/2, and so using y minus y1 is m into x minus x1, we get y minus 1/2 equals minus 2 x minus 4, and expanding the bracket, y minus 1/2 is minus 2x plus 8, and we have y equals minus 2x, and adding 1/2 to both sides, we have 8.5, which is 17 over 2. That's the equation in y equals mx plus c format, but again, if we need it in ax plus by plus c equals 0 format, we would write it y, we multiply by 2, 2y is minus 4x plus 17, because we need integer coefficients, so no fractions, and we put everything onto one side. 2y plus 4x minus 17 equals 0. A slightly more difficult problem here. We have the line L joining A, 4k minus 3, and B, 1 minus k, is perpendicular to the line 2y equals x minus 3. find the coordinates of the points where L cuts the axes. And here we have these 2 points A and B are in terms of this unknown value K, which we'll need to find. So we know that L, we need to find the equation of L, and we know that it's perpendicular to 2y equals x minus 3. So we need to find the gradient of 2y equals x minus 3. So divide by 2 to get in the form y equals mx plus c, and we see that the gradient, we'll call it m1, equals a half. So the gradient of L, and I'll call that ml, equals minus 2, because the two gradients must multiply to give minus 1. A half times minus 2 is minus 1. Now, that gradient is obviously the gradient of AB. So we can say that the gradient of AB is the difference of the y coordinates divided by the difference of the x coordinates. So that would be minus 3 minus k divided by the difference of the x coordinates, which are 4k minus 1. And that is equal to minus 2 ml. Okay, so we'll just solve this equation, multiply by 4k minus 1, and this numerator here. We have minus 3 plus k equals minus 2 4k minus 1. Expand the bracket, minus 3 plus k equals minus 8k plus 2. And solving that, bringing the 8k onto the left, we'll have 9k equals 5 by adding 3 to both sides. So k is 5/9. So we can find the coordinates of A and B now by substitute k into the coordinates here. So A would be 4 times 5, 20 over 9 minus 3, and B would be 1 and minus 5/9. So we need to find the equation of the line L. So using again y minus y1 is mx minus x1, and we can choose either A or B as x1, y1. I'll choose B. So we'll have y minus 5/9, so that's plus 5/9, equals the gradient m, which is minus 2, x minus the x coordinate of b, which is 1. Expanding the brackets, y plus 5/9 is minus 2x plus 2. So y equals minus 2x plus 2 minus 5/9, which is 18/9 minus 5/9, which is 13/9. So L will cross the x-axis when y equals 0. So we'll have minus 2x plus 13 over 9 equals 0. So x equals 13 over 18. And it crosses the y-axis when x equals 0 or y equals 13 over 9. So L crosses the axes at 13 over 18, 0, and 0, 13 over 9. Now return to Study Smart and where you'll find a practice exercise where you can practice problems of this kind.